Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem based on the Euler's formula. Okay, so which is based on the columns. Okay, so as in previous three videos we have already discussed about the columns and Euler's formula, and we have also derived the Euler's formula, and we have seen this formula how to apply for various end conditions. Okay, so in this video we will just simply solve a numerical problem. So let's read the problem, and while reading we will note down the important parameters. A column of timber section 15 centimeter into 20 centimeter is 6 meter long. Okay, so it is given that area is 15 centimeter into 20 centimeter, or you can see width is equal to 15 centimeter and height is equal to 20 centimeter and length is 6 meter. Both ends are being fixed, so this is the important thing, both ends fixed. Okay, Young's modulus of timber is, so E, value of E, Young's modulus of elasticity is 17.5 kilonewton, means 10 to the power 3 Newton per mm square. Determine crippling load and safe load of the column. A factor of safety is 3. Okay, so what is the factor of safety? Suppose a column has to take a load of 10 kilonewton. Okay, so we will design it for 30 kilonewton so that it is 3 times stronger than the original strength required. That is called the factor of safety. We make it more safe. Okay, now what is crippling load? So first of all, this is both end fixed condition. So if this is a column, then here both the ends are fixed. Okay, so this will cripple like this, this will cripple like this, it will be up to here and it will become like this. The buckling will take like this. So what will be the effective length? And if you remember from our previous video, you can see in any book, effective length LE, effective length of both and fixed is L by 2, original length by 2. Okay, and formula for Euler's formula is 4 pi square EI upon L effective square. Okay, so we will not put the original length here, we will put the effective length here. L effective is L by 2 because end condition is both ends are fixed. Okay, now if you see this, all the units are different. Here it is centimeter, here it is meter, here it is here it is mm. So we will convert everything into same unit, so we will convert everything into mm. So here L is equal to 6 meter, so it will become 6000 mm, because 1 meter is equal to 1000 mm, it will become 150 mm, it will become 200 mm. Okay, because 1 centimeter is equal to 10 mm. So what will be the L effective? So L effective is L by 2, which is 6000 divided by 2, which will be equal to 3000 mm. Okay, and after this, what will the moment of inertia I for a rectangular section? It is bh cube by 12. So if this is a column, okay, this is a column, so it can bend in two ways. Either it can bend like this, or it can bend in our plane, which we cannot see. If we see from front side, it will look like this. It can also bend in this direction, inside of the screen or outside of the screen. So it can bend in any of these two. So we will calculate I for both x axis, this is x axis, this is I y axis. So this column will bend in that direction where I will be minimum, because I also shows the strength of the section. Okay, So if I will be minimum in x direction, then this column will bend in x direction. If I will be minimum in y direction, y axis, then it will bend in y direction. Okay, so we will calculate both. So ixx will be equal to so for ixx, around this axis width is b is this width. Okay, this width is how much? This is given as 15 centimeter, which is 150 mm. So 150 into h is height of this cross section, which is 20 centimeter or 200 mm. So 200 cube divided by 12. Okay, so if you will calculate this, then you will get 10,000 into 10 to the power 4 mm to the power 4, or it will be 10 to the power 8 mm to the power 4. So this is value of moment of inertia around x axis. If we calculate Iyy, then this was the original cross section. If we calculate around this, and this will become b and this will become h. Okay, so it is bh cube by 12. So what is the value of b now? Value of b is 20, as you can see, 20 into what is height, this width will become height, so it is 15 cube divided by 12, and this is in centimeter, so you can write like this in mm. Okay, 200 into 150 cube by 12. So if you will calculate this, then you will get 5625 into 10 to the power 4 mm to the power 4. Okay, now which one is less? If we see the value of Iyy is less, means this cross section is weaker along Iyy axis, so buckling will take only in that direction. So we will consider Iyy because it is minimum. So column will buckle in Iyy axis. So what was the formula of buckling load? P is equal to pi square EI upon L square. L effective it was, so it will become pi square into what is E. E is given as 17.5 into 10 to the power 3. 75.5 into 10 to the power 3 into what is value of I is 5624 into 10 to the power 4 into what is L is 3000 square. Okay, so if you will calculate it, you will get 1079480 Newton. Okay, so if you will calculate it, into Newton and kilonewton, if you convert it into kilonewton, then you will divide by 1000, it will become 1079.480 kilo Newton. So this is the value of load. And what is the safe load? Safe load is equal to crippling load divided by factor of safety. Factor of safety. So it will be 107 point. Sorry, it was 1079.48. 1079.48 divided by 3. So it will become 359.8 kilo Newton. So this is our safe load. I hope you understood this problem. If you have any doubt, then you can ask in the comment section. And thank you for watching this video.